Much like our other examples of hypothesis testing, testing for proportions is quite easy and very similar. Suppose we have a population proportion, denoted by pi, equal to 0.82. But our sample says that we've got a sample proportion of 0.80. Well, we want to test and find out, of course, is our null hypothesis, HO, pi equal to 82, true? Or is it not equal? So for population, for our z-score, we have our sample proportion minus our population or theorized proportion divided by the square root of our population proportion times 1 minus the population proportion divided by n. And this is our standard error for this. And we'll see that again, the standard error used when we use confidence intervals next time. So how does this work out? Well, just like before, we plug in our numbers. So for our p, we have 0.80. For our pi, we have 0.82. We're going to divide it by the square root of pi, 0.82, times 1 minus pi, 0.18, and divide by n. And here our n is 100 again. Make sense? So, this becomes our z-score, which I'll leave for you to calculate out completely. Then, very similar to our prior example, if we are given this question for alpha of 0.01, which if you remember is our level of significance, then we can look in our z-table and find that these are our rejection regions. This area to the left and this area to the right. If our z-score here falls inside this region, then we cannot reject the null hypothesis. If it falls out here in the rejection regions, then we can reject the null hypothesis.